Hi PChem, I'm putting together a couple of videos for our next chapter for you to watch before we meet on Wednesday, and then set you up for doing some problems on the few days we're going to take off for the Easter holiday. The chapter that I'm going to talk to you about today is Chapter 6, Non-Electrolyte Solutions. You've actually done some calculations that were from this chapter on the first day of class. I assigned you some problems. Problems 5 through 12 are really just extracted from the first few problems from the end of the chapter. So if you double check that answer set, you could just refresh your memory on some of the vocabulary when you're dealing with solutions. For this slide, I just want to make a quick reference to some of the most common concentration units and why you might want to use one over another. And the first one I have written here is percent by weight. The advantage of this concentration unit is you don't need to know the molar mass. Clearly that's an advantage if you have a solute that's, let's say, a really big molecule like a protein or nucleic acid, where you don't have that information, but you could still express its concentration by how much you have after you've gotten that information from a balance. It's also temperature independent, which we're going to talk about in a minute as being important for concentration units. So percent by weight has that usefulness. Mole fractions we use a lot in the gas phase, if you recall. Partial pressures of gases, for example, or vapor pressures of solutions are very frequently expressed in this way. Partial pressures. Again, this one is also temperature invariant, or independent, I'll call it. Now, molarity is the one you probably use the most in something like general chemistry. This one is temperature dependent. And the reason, of course, is in the units that are in the denominator. So if you put moles of solute over liters of solution, obviously, a cold solution versus a warm solution will cause that solution to expand or contract. And so that's a drawback. However, they're easy to make. And the principal reason is that if you have volumetric glassware, volumes are very, very easy to measure accurately and precisely. Volumes are easy to measure. The temperature independent concentration that a lot of the thermodynamic properties use is the molality, of course, because if you have moles of solute over kilograms of solvent, you're going to keep that same numerical value regardless of what the temperature is. In general chemistry contexts, we use the molality principally for colligative properties, and we'll do so again in this class.